right, now we're going to skip to 4-6 and do congruence in right triangles. What this is going to do is create one more triangle congruency statement for us. So let's look at these few right triangles. We have this pair number 1 here. Are these triangles congruent? Well, we have sides matched up, we have an angle matched up, and we have a side matched up. So it's side, angle, side. Even though this angle is a right angle, 90 degrees equals 90 degrees. All right? We also have this one where we have a 90-degree angle matched up. We have sides matched up, and we have another angle matched up. So here we would have angle, side, angle. In the pair number 3, let's look at what we've got. We've got angle, we've got another angle, and we have a side. So here we have angle, angle, side, because the side was not in between our angles. So we can still have regular triangle congruency statements with right triangles, but you may also have this new one called hypotenuse leg that only works for right triangles, because hypotenuse and a leg are only terms we use with right triangles. So it says if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then the triangles are congruent. Okay, so the conditions for HL, they must be two right triangles, and we know they are right triangles because of these 90-degree right angle boxes in the corner. The triangles must have congruent hypotenuses. Hypotenuses are the sides across from our right angles, so this one right here. All right, and then they must have one pair of congruent legs. So legs of these triangles then are the other sides of these triangles, and it has to be the corresponding one. So when I say this one on the bottom is congruent, it needs to be, again, the bottom one over here that is congruent. So you have a hypotenuse and a leg, and we know it's a right triangle because of our right angle boxes, so we could use HL. So another way we can look at this is as SSA, because we do have a side, and an angle. But remember, spelled backwards, that's the bad word, which is not a triangle congruency statement. But is this valid for right triangles? Yes, because it is hypotenuse leg, and we will mostly just call this HL. Okay, so SSA only works for right triangles, and instead we're going to call it HL. So we should still never see SSA as a reason for triangles to be congruent. So two kinds of proofs that you would see with HL as the reason. So we are going to have that BE bisects AD at C. So BE is right here, AD is right here, so BE bisects AD. Okay, so they don't bisect each other, BE bisects it at C, so I would get that congruency statement there. I have that AB is perpendicular to BC. So AB is perpendicular to BC. To be perpendicular means I form a right angle. All right? Now I also have DE is perpendicular to EC. So DE, perpendicular to EC, puts a right angle box right there. And then I have AB is congruent to DE, so I can mark those as congruent right there. So all of that information I was able to put on my picture just from my given statement. I'm not going to write out all of that, but all of this in our given statement would need to be statement number 1, reasoning being given. So let's break this down into a proof. You're able to put so much on our picture, so we need to put that more in words. Okay, so BE bisecting AD at C, that made AC congruent to DC. So AC, whoops, AC congruent to DC, that came from the definition of bisect. Okay, because we used that first statement of our given that BE bisects AD at C to get this congruency. All right, the next statement we used AB perpendicular to BC to get this right angle right there. So we were able to say that angle B equals 90 degrees. And we also used that DE was perpendicular to EC to say that angle E was 90 degrees. And those were both from the definition of perpendicular. Okay? So the fact that we knew two lines were perpendicular let us mark angles B and E as right angles. All right, and then we were able to mark AB congruent to DE. All right, so let's see what kind of information we have here. We have one side matched up, we have another side matched up, and then an angle. So we would have SSA, but these are right triangles. So that actually means, let's look if we have hypotenuse leg. Is one of these sides our hypotenuse across from our right angles? Yes, it is. And then do we have corresponding legs? And do we have a right angle? Yes, we do. So then these triangles are congruent. ABC is congruent to triangle DEC by HL. Alrighty. The next one we have is that AD is the perpendicular bisector of CE. Perpendicular bisector does two things. It makes lines that are perpendicular, so we would get a right angle, and bisect means to split up, split in half. So let's see, AD right here and CE right here should be meeting at a right angle since they are perpendicular. So that would put right angle boxes here and here. Those are also vertical angles. That's why we can put that right angle box on both sides. All right. And then we have that they are bisectors as well. So that means I've got AD is the perpendicular bisector of CE. So actually it's only going to bisect CE. So I can also say that at this point right here where they intersected, it split it in half into two congruent pieces. And then another given statement to us was that CD is congruent to EA. So I've got that congruency marking there. All right, so we have our given. So all of this information, again, I'm not going to write it all out, should be our first statement. And the reason is always given. So now we use what we got from our given. So using AD as the perpendicular bisector of CE, I was able to mark that angle ABE was congruent to angle DBC. I was also able to get that CB was congruent to EB, all from the definition of a perpendicular bisector. Okay, so all that information I was able to draw on my picture. Now I can look and see if I have a triangle congruency statement or if I need more. I've got right angles and I have hypotenuses and I have a corresponding leg, so I do have HL. So we are already done with this proof. Triangle CBD is congruent to triangle EBA by HL. All right, so those are some proofs that you might see with hypotenuse leg. Just know to add this to your collection of triangle congruency statements. All right, see you in class.